Okay, so in this video we're going to have a look at angles in parallel lines. Now there are a few different types of angle rules that I'm going to assume that you already know throughout this video, such as angles on a straight line equaling 180, angles in a triangle equaling 180, things like angles in a quadrilateral equaling 360, and also things like vertically opposite angles being equal and stuff like that. So we are purely going to be looking at the angles in the parallel lines. Now we're going to start off with a nice easy little question, just look at all the different types of angles within it, and then we are going to move on to some of the more complex questions and some of the larger problems, okay? But grab a piece of paper, grab a pen, make some notes, and we're going to kickstart having a look at this question here that says work out the size of angle X and you must give reasons for your answer. Now this bit's really important. It says you must give reasons for your answer. Now some of the time I'm going to write down my reasons, okay? When you are doing these questions you always need to write the reasons down, but I'm going to try and minimise the amount of writing that I do just to save a little bit of time as we're going through this, okay? And I'll just speak about them instead. But we will write them down initially and start thinking about maybe a little shortcut that I can write down just so that you know when and where we're going to write down those reasons. So having a look at this question then, we've got these parallel lines, okay, and the parallel lines are indicated via these little arrows here. Now when you have a line that is going through those parallel lines, so from B down to E, this one here, there are lots of rules and angle rules around about these angles. I'm going to extend that a little bit further because it does go all the way through there. Okay, so obviously in this question we've been given the angle of 47 down there and it wants us to get all the way up to that angle of X. And to be honest, there's probably about 5 or 6 different ways of actually getting there, but when it comes to a question like this, you have to almost ignore what we're actually looking for. And we're just going to find everything. Okay, we're going to have a look at working out every single angle around all these points here. Now when it comes to obviously the parallel line rules, there's a few that we need to know, okay, and that's how we're going to jump from one line up to the other. And what I mean by that is that's how we're going to get from down here on this line and we're going to jump up to this line here. Okay, so those little rules that we're going to have a look at. The first of them, and there's 2 different ways of writing this, but the first of them, and you hopefully recognise this, it makes this Z shape, okay? And those are called alternate angles, okay? So if we make this little Z shape here, okay, that's going to be an alternate angle, and our reason there is that alternate angles are equal. And there we go, alternate angles are equal. There we are. And throughout this video, obviously, if we ever use an alternate angle, that's the exact reason that we have to give. We have to say that alternate angles are equal. That is a reason, okay? We don't just state that it's an alternate angle. We actually give that as a reason and say exactly what that means and in terms of how we get in there. So that angle there hooks particular angles in it, hooks these two either side, and those 2 angles are equal. But of course, you could have that angle going along the other side as well. Okay, we could make what kind of looks like a backward Z. I could make a little Z going this way as well. And that hooks in this angle here, X, and this angle down here. And as you might be able to already see, that's going to give us part way or a little bit of a hint towards how we're going to get to that final answer there. But okay, let's get rid of that because there are other angles as well that we might have throughout these questions. And one of them is when it creates this F shape. Okay, and these angles here, I'm going to draw this out. So a little F shape, and they are called, and it hooks in this one and this one underneath the F that time, and they're called corresponding angles, and the reason again is that corresponding angles are equal. Okay, there we are, corresponding angles are equal. Okay, that's another reason that we might have throughout this. So as you can see, if that's 47, this is also going to be 47 up here. Okay, but just thinking about different ways that we can get there. So that's 2 different rules, and you might have already spotted we could use either of those to actually get our final answer up there. But again, before we move on, there is one more angle rule that we might have to use throughout this video, and that is when it forms this little C shape here. And angles within that, again the ones that they hook in there, these ones here, they add up to 180, okay, and they are called co-interior angles. There we go, so I'm just going to draw this as a little C, and co-interior angles add up to 180. There we go, so co-interior angles equal 180 degrees or add up to 180 degrees. Okay, so obviously those are the 3 angles that you need to make sure that you've got, or the 3 angle rules that you need to make sure that you've got written down throughout this video, because we're going to be using at least one of these in every single question throughout the video, so you need to know these pretty well and sort of recognize how to spot them. But essentially you are always looking for a line that jumps or moves from one parallel line to another, and in the case of this one on the screen here, it goes from B to E and it does extend down to G, but that's our line that's going through the parallel lines there. Okay, so we're going to have a look at actually going about answering this. So we're going to see how we can actually get to an answer. But let's have a look and see which one of these angle rules we might be able to use. Now, there are lots of different ways of going about this. Okay, in fact, we could go, and we'll talk about 3 different ways. Okay, so I'll start with one way. One way we could do is we could get this angle here, then say that that's 47. So not one of the rules that I've talked about, but when we get this little X shape going along here, 2 lines crossing over, it creates these 2 angles here. And this angle here is vertically opposite to the other angle there. So I would say that that angle there is 47 because vertically opposite angles are equal. There we are. And you don't just say opposite angles, you do say vertically opposite angles are equal. There we go. Are equal. Right, there we go. So vertically opposite angles are equal. That's my first reason there. And then I could move on to another angle, okay, and I could actually spot one of my parallel line rules. Now I could either from there get my Z shape, and that would give me this angle up here, and that would be alternate. Okay, I could say that that's 47, okay, because alternate angles are equal. There we go, alternate angles are equal. And then from there, I could do angles on a straight line. Okay, again, let me just get rid of this Z shape. There we go. We've got angles on a straight line. So next to that X there, these 2 angles have to add up to 180. So I would simply do 180 and take away 47. So 180, take away 47, and that would give me 133. There we go. That'd be 133 degrees as my final answer. Okay, and showing that there, 180 minus the 47, and obviously just always showing you working out there. So my final reason, because it does say you must give reasons for your answer, I would say angles on a straight line equal 180. Now I'm not going to write that down again, I'm going to stop writing some of these down because it's going to make this video about twice as long if I have to keep stopping and writing them all down, so I will just speak them instead. But there we go, that's one way of getting there. There are other ways as well. I could have maybe not found this alternate angle. I could have then had a look at this as the co-interior angles look. I could do 47 with that one, makes that backward C shape, and those 2 angles have to add up to 180. So obviously I'd do 180 take 47 again, that get me straight to the 133. But again, there are lots of different ways that I could get there. I could have even done angles on a straight line here. I could have done next to the 47 is 133 and got that one first, and then we could have done, I'll swap to the same colour as the picture over there, there we go. I could have done my F angle shape there, which is a corresponding angle. So I could have done corresponding angles are equal as well, and I could have done any little combination of those on different sides of the line, but essentially there you just got to find your way of getting there, okay, and make sure that you label and describe whatever reasons you are using, okay. That's what's important, in that whatever way you do it, you need to obviously give the reasons for those. So the particular way that I did it, and I did it on the first one, I did vertically opposite angles are equal, then I did alternate angles are equal for this one, and then I did angles on a straight line equaling 180 for my final one there. But there we go, there's some of the rules. Obviously you need to just make sure that you've had a practice on some of those. I'm going to have one question for you to have a go at, and then we're going to have a look at some slightly harder problems applying some of these. Okay, so here's your question. It says work out the size of angle X. You must give reasons for your answer. And what I would say is try and see if you can get it done in 2 steps. See if you can make it work in 3 steps. Okay, maybe even see if you can do this question in 3 different ways, just to see if you can develop your understanding of all those different angle rules, okay? But there's a way of getting the answer here in 2 steps. There's a nice way of getting the answer in 3 steps. And I think there's probably another way of doing it in more steps than that. But see if you can do it in 3 different ways. Pause the video there and we'll go over the answers in a sec. Right, okay, so the quick way of getting there then. Number 1 is we've got this nice straight line here. So next to that 126, I can find that one out straight away because I can do 180, take away the 126, and it gives me 54 degrees. There we go. And that would give me that one there. My reason would be angles on a straight line equal 180. And I'm going to shorten this down. I've got a little symbol for that. Okay, you can't use this in an exam, but there we go, that means straight line, and straight line equals 180, just a way of speeding this up for you so you don't have to watch me write that down all the time. But there we go, straight line equals 180. From there we can use one of our parallel line rules, okay, we've got that 54, we want to jump up to the next one, and I can get this little Z shape, there we go, and it jumps me up to that one straight in there, and that also has to be 54 degrees because alternate angles are equal. And I'm going to shorten that down, I'm going to do the shape Z equal, there we go, that's my little shorthand way of writing alternate angles are equal for you. Okay, so they would be my two reasons. One is angles on a straight line equals 180, and then obviously that one's 54 because alternate angles are equal. Just on a little side note here, do watch out because you can't say Z, F or C angles. You have to use the proper language for these questions when you're giving your reasons, okay? But obviously just so that you don't have to watch me write it down over and over and over again, I'll shorten them down for you. But there we go, that's one way of getting there. Let's have a look at one more quick way of how you could have got there in another way. Before we move on, you could have done a similar one to what we did last time, so you could have done 126 here, and again vertically opposite angles are equal. I'll do a little X, there we are, vertically opposite angles are equal, and then you could have either jumped straight up to here using the C angle, there we go, well, sorry, your co-interior angle, definitely don't say C angle, there we are, so you got your co-interior angle equals 180, and you could do 126 from 180, which is 54. That's another way you could have done it, or obviously you could have taken some slightly longer steps. You could have even jumped over to this side here, and you could have got your alternate angle there, which is 126, and then angles on a straight line and got your 54 next to it. Okay, obviously just giving all your reasons, but there's so many different ways that you can get the answer in these questions, which is why I said straight away, don't think about the final answer, just think about finding any of the angles and moving around the diagram and giving your reason at each stage. Okay, but there we go, the answer was 54, and obviously the reasons will be dependent on however you got to your final answer there. But there we are, let's have a look at some slightly harder problems now and actually applying this. Right, okay, so when we start looking at these types of questions, there would be some more information with this. Now, I have extracted the information away from the question just so that we can focus on the mathematics behind it, but there'd probably be quite a lot of information here. So looking at the diagram for a start, it would probably say something along the lines of C to F being a straight line, okay? Just telling us that obviously we can apply straight line rules at these angles, we can apply straight line rules at these angles. But obviously I've taken the information out there, so we are going to just be assuming that these lines are straight lines for the majority of these questions, just so that we can focus on the maths here, but you would have some of that extra information. It is also quite likely that you would be told that this line here, A to E, and this line here, D to E, are the same length, or that they're equal to each other, okay? But as this is given to us on the diagram, indicated via these lines here, okay, we know that they're the same length anyway, so we're not going to worry too much about some of the language that would be behind these, more just practicing the methods and the process, but just so you know, there would be quite a lot more information with this. Now let's have a look at this question then. Now straight away, these little lines, they tell us that this is a particular type of triangle. If two lines are the same length in a triangle, that means it's an isosceles. Now with an isosceles triangle, the angles underneath it, so underneath those little dots here and here, they are equal. So at any point, if we can find one of those angles, we'll be able to find the other one because we know that they're going to be the same as it's an isosceles triangle. Okay, and the reasoning there is that angles in an isosceles, the base angles are the same in an isosceles. So let's have a look and see if we can get there. I'm not going to focus on those angles straight away. I just want to see what can I find, if I can find any just yet. Now we've been given the angle of 38 up here. So 38's up there. Here's our parallel line. And here's our other parallel line. So straight away we can jump between the two. Okay, so we can actually take this going down here, and then jumping across. And there we go, that's an alternate angle just down here that it's been hooked in by, and that is 38 degrees. There we go. So again, alternate angles are equal. I'm just going to write alternate equal. There we go. That's a bit shorter, that's a bit better than drawing one of those Z's. So alternate angles are equal. Now we can go about having a look at these angles in the triangle, because we've got one angle in the triangle, and as it's an isosceles, I can find out what's left to split between the two base angles, as we know that these two are the same. So if I take away 38 from 180, so 38 from 180, and let's write that down, 180 minus 38 leaves us with 142. There we go. And as those two base angles are the same, there we go, we can split that in half, so divide it by 2, and that gives us 71 for both of them. Now I haven't written down this reason yet, so I'm going to write this one down, and that is that base angles in an isosceles are equal. There we go, base angles in an isosceles are equal. There we are, and that's my reason for getting the 71 here. There we go, so they're both the same. Now we can finish this question off, because obviously this is a straight line, so just next to that 71 there we have two angles together, and they both have to add up to 180. So this one here I can find straight away. I can do 180, take away the 71, and that leaves me with 109 degrees as my final answer. And again, my reason there would be angles on a straight line, which I'm going to shorten down with my little picture again. So straight line equals 180. There we go. But there's my final answer, 109. And again, we had three reasons there. One was the alternate angles being equal for the 38. The second one, base angles in an isosceles are equal. And my final reasoning there was angles on a straight line equaling 180. Right, there we go. So that's how you're going to tackle some of these slightly harder problems. Going to have a look at one more before you have a go. And here it is. So a very similar question to the last one. We have got a triangle within our parallel lines. We're working out one of those angles up there. I'm going to forget about that one for the moment. I'm just looking at the diagram. So we've got these little dashes on here. Sometimes you might have two dashes. It means the same as one. It just means that those side lengths are the same length. So again, we have an isosceles triangle. And the angles underneath that are this one and this one. Remember, it's been flipped on its side there, but if you were to look at it standing up, there we are. These are our two base angles. And this is where our little lines would be, or in this case, 2. Okay, so this is on its side, but it just means that straight away we can find this angle up here as 50 degrees. There we go. And again, our reason there will be base angles in an isosceles being equal. There we are. I'm just going to draw it like that. Base angles in an isosceles are equal. So on to our next one. We've got to find angles in a triangle now. So that's what we could move on to next. We can get this angle here. Okay, so obviously angles in a triangle equal 180. So we've got 180. Take away those two 50s there. The total of the two 50s is 100. And if we take those away from each other, that leaves us with 80. That's going to be 80 down there. So lots that we could find. Okay, obviously we could find angles on a straight line. We could find this one here, take it away from 180. We could even find this one here, take that away from 180. But straight away now we can actually jump up to the top. We can go across here, up there, and hook that in for one of our alternate angles. So that there is going to be the same as the 80. Okay, so that's also 80 there. And again, that reason, we use this quite a lot, this alternate angles one. Alternate angles are equal. There we are, I'll shorten it down for you again. So there's all our reasons, there's our answer. And all we really have to do is find angles in a triangle and then do an alternate angle. So nothing too bad there, seems quite nice actually. I think this alternate angle is used a lot more, or it can be used in most questions, okay? We do still use the corresponding angles and co-interior, obviously, they are just as important, but I do tend to find that I use the alternate angle rule a lot more than any of the others, okay? But I could have used co-interior angles here. I could have found this angle just here on the straight line and then use co-interior angles as well to find the one above. But there we go, just some ideas on how to tackle these sort of questions. So here's a couple for you to have a go at. Okay, so hopefully you're obviously writing some of these down. So draw a little sketch of these, write them out. Do make sure you write down your reasons. It's very important to get into good habits and making sure that you're writing them down, even though I am sort of skipping them over a little bit quicker just to make it a bit easier for you to watch. Do make sure you please do write down those reasons. It's very, very important, okay? But here's two questions. So pause the video there, have a go, and we'll go over the answer in a sec. Right, okay, so this one on the left then. So we've got an isosceles triangle, and there we go, underneath those two are the same. So looking at this then, next to the 142, that's on a straight line, we can find that. That's the top angle in the triangle. So 180, take away 142, leaves us with 38. There we are. We've had a question very similar to this. So if that's 38 then, we can actually find the two base angles in the triangle. So take that away from 180, 180 minus 38, is 142. I'm just going to write that working out down. So 180 minus 38 is 142. So to get these two base angles here, as they're the same, we can do 142, divide that by 2, and we get 71 degrees. There we go. So both our base angles there are 71. So again, our reason for that, base angles in an isosceles triangle are equal. Now we've got to see how we're going to get into that x there. Now, what I can see is we've got an alternate angle again. There we are, so we can get alternate angles. Alternate angles are equal, aren't they? So we can get down to that one, and that one there is 71 degrees. And again, our reason there, alternate angles are equal. And again, you can just label this around the diagram. You can write it out in sort of mathematical language as well. So from A to E to D makes that angle. So I could say AED equals 71 degrees. Okay, because alternate angles are equal. Okay, and if you want to write them down like this, that's absolutely fine. They are alternate angles are equal. Okay, I'm not going to stress too much about, super correct ways of writing them in this particular video though. We're just going to focus on actually getting towards the answer and making sure we write down all our reasons, okay? But just as a little note, this is a really nice way of writing your answer down and just making sure that whoever's looking at your question can really understand exactly how you got each angle and exactly what the reason was for each particular one. But it is fine just to label it on the diagram as well. Okay, so for this one here, we've got a straight line equaling 180. Then we had base angles in an isosceles being equal, obviously writing down the full words for that. There we are. And then we had the last one there, alternate angles are equal. Right, onto the one on the right then. Let's have a look. So, very similar to some of the others we've looked at. We've got an isosceles triangle, so these two here are equal. We've got the 68 there, and we've got our angle of x in the bottom left. So, straight away we can use alternate angles. Okay, we've got the 68 jumping us down into the bottom of that triangle there, so that is also going to be 68. There we are, 68 degrees. Let's get rid of that. There we go, so that's 68 degrees. And again, the two base angles are equal, so that one there is also 68. Now all we need to do to finish this off, this is quite nice actually compared to the last one, there's a little bit less work in, is find the last angle here in the triangle. Now those two are obviously 68, so we want to do 180 and take away the total of those. So 68 times 2 is 136. So we'll do 180, take away 136, and that leaves us with 44 degrees as our final answer. And again, all the same reasons we had on the last question. So again, thinking about the language and the way I could write this down, I could say BED, let's have a look, B to E to D is 68 degrees, okay, because alternate angles are equal. Just going to write that down, alternate equal. Then the next one we found was EBD, the other side of the triangle. Let's have a look. EBD. It was 68 as well. Okay, because base angles in an isosceles, I'll just draw that little sketch there. Base angles in an isosceles are equal. And then for the final reason there was BDE. The last one there, we got that was 44 because angles in a triangle equal 180. There we go. Obviously writing down the full language there. But there we go, that's how to answer a couple of those. Now let's have a look at something slightly different. Right, okay, so something that doesn't look very nice here. It says work out the size of angle x, you must give reasons for your answer. Now to be fair, you've got all the mathematical knowledge in order to answer one of these questions. So, I mean, there's nothing wrong with just pausing the video, having a go, see if you get it, and then we're going to talk about it. So there we go, we're going to have a little look. Now getting this one here, we've got lots of different things that we have on the diagram. We've got a triangle at the top, just here. Okay, we've got a parallelogram sitting just there. We've got another triangle sitting here. I'm going to run out of colours, I've got so many shapes. And as well as that, we've got a huge big triangle all the way around the outside. Okay, so there's loads of shapes that you can be looking at on this one, and we're going to have a look at how to actually approach it. Now it says to find that angle x, but I'm just going to ignore that for the moment and see what I can find. Now straight away what I can find is this angle next to the 55. It's on a straight line. Whether that helps me or not I don't know, but let's just go for it and just see what happens. So take away the 55 and that leaves us with 125, and then again that'd be angles on a straight line equal 180. Now I can think about this parallelogram. Now I've got those parallel lines there, and an angle, this is obviously something to do with parallelograms as well, is that when you have a parallelogram, obviously because the lines in a parallelogram are parallel, you get these C angles, okay, which is obviously co-interior angles. So above that 125, inside the C, that's also 55. There you are, because co-interior angles are equal. When it also comes to a parallelogram, you've got, if I just get rid of that, there we are, you've also got the opposite angles in a parallelogram are equal. Okay, so we could either do that, or looking at that 55, look, that goes up to these parallel lines. This one up here is also 55, okay, which matches our opposite angle in the parallelogram. So loads going on here. Okay, so let's get rid of that. And then as well, obviously in the parallelogram here, that's going to be 125, okay, because in the parallelogram you've got opposite angles in a parallelogram are equal, and that applies to these ones as well. There we go. So we found all those angles in the parallelogram. Obviously we're not getting close to that x over there just yet, but at this point we might actually just be able to get there. Okay, we've got this big triangle around the outside. Okay, so I'm looking at the whole triangle right now, and within that triangle we've got one angle up here, let's swap colours, of 95. We've got this one down here of 55, so we'll definitely be able to find this one here because they've all got to add up to 180. So 95 plus 55 is 150, which leaves us with a gap of 30 to make it up to 180. And again, don't forget to show you working out for all of these. That was 180 minus 150, and that left us with 30. So there we go, that's one of the other angles there. And there's a couple of ways that we could get to this final one now. We could even go for getting straight into that answer, but to be fair, you've also got, and I just like finding all of the angles, to be honest. We can find every single angle on this picture. We've got the triangle there, so we could find this little angle here. We could actually just jump straight in using alternate angles, but let's just find this one as well. We've got 55 and 30 in that little triangle. 55 plus 30 is 85, and if you take that away from 180, that leaves with 95, so that one there is 95. And then you've got these three angles here on a straight line, okay, just obviously these three going along are on a straight line. So actually they just need to all add up to 180. So we can find this one here. 55 plus 95 is 150. So again, that has got to be 30 degrees because angles on a straight line equal 180. But of course I did say we could have got there a little bit earlier. I could have actually just used my alternate angle rule. There we go, to take me up to that one as well. So there's so many different ways that you could get there. You can literally find every single angle in this picture. We could find this one as well next to the 125. That's also 55 angles on a straight line. And you could even find this one here. Look, you've got that little triangle sitting on top, and 95 plus 55 is 150, and the gap there is also 30, look, which is vertically opposite the one we were looking for. So many different ways for getting there. It just depends on writing your reasons, depending on the route that you take, and making sure that you write them nice and clear around the outside of your diagram. Okay, but there we go, there's another type of question that we could have. We're going to have a look at another one. Right, okay, so again, feel free to have a go at this one. Slightly different. You've got a quadrilateral in the middle there, and you're just going to have to be a little bit careful with the alternate angle rules or the corresponding angles or whatever it is you're going to use. Just be careful, just because this line, I'll just highlight it here, doesn't stretch all the way down to here. Okay, so that one there cannot be used in terms of finding an alternate angle or anything like that. But as a little hint, this one can. So if you want to just have a go, pause the video and have a go, and we're going to go over it anyway. So for the first thing that I want to do in this one, I need to find what angle can I find, if any. Now it does actually give me a right angle in this one, so I'm just going to put the number in there, 90, just because that might help just to clarify things. And now we have these three angles on a straight line. Whether that's going to help me get towards the X or not yet, I don't know, but I can find that, so I'm going to. So 90 plus 32 is 122. And if we take that away from 180, it'll find this one for us. So 180, take away 122. And what does that equal? 180 minus 122 is 58. There we are, so that one there is 58. Now that I've got that, actually, yes, I can apply an alternate angle rule now. I can jump from 58 down to here and hook that one in there. So that one is also going to be 58 degrees. There we are. And again, my reason for that, alternate angles are equal. Now we can go about finding the other angle in the quadrilateral, and that is actually going to be our final answer. So actually it wasn't too bad getting there. So what did we have? We've got angles on a straight line as our first reason, equaling 180. Then down here we had alternate angles are equal. I'll just write alt equal. There we go. And for our final one here, we're going to use angles in a quadrilateral, as this final shape here that we're looking at in the middle is a four-sided shape, so therefore they add up to 360. So if we add up what we've got 90 plus 58 plus 124, add those up on a calculator, 90 plus 58 plus 124 adds up to 272, and we just want to take that away from 360. So there we go, 360, take away 272, and let's see what that gives us. There we are, that is 88 degrees. Right, there we go, and there's our final answer. Always just go back and double check. 90 plus 58 plus 124 is definitely 272. 360, take away that, is definitely 88. There we go. So always just make sure you're happy with your answer. And let's just finish that off just by highlighting that. And just remembering the fact that obviously we did need to give one more reason, and that was that angles in a quadrilateral. There we go. That's not an L. There we go. Quadrilateral equals 360. Okay, obviously giving a full reason there. Angles in a quadrilateral equal 360, and just making sure that it's all nicely labelled around the outside. But there you go. That's how you're going to find some of these angles in these parallel line questions. Hopefully this is just helping just to break it down a little bit and have a think about how you approach these questions. Okay, so I've got one more question for you to have a go at before we finish, and here it is. Okay, so your last question. This one doesn't look very nice. In fact, it looks pretty horrible. One thing that can be quite nice to do in this one is just to look at the top half and then look at the bottom half, as they are just a mirror image of each other. If you have a look, that central line there, D to G, is just basically a mirror image, top and bottom. So have a go at this question, pause the video, see how far you can get, see what reasons you can get down, and we'll go over the answer in a sec. Okay, so looking at the top half then. Now we have a little isosceles triangle here, okay? And if we can find one of the angles in that, we can find all of the angles there. And actually thinking about this, we can get an alternate angle, okay? You've got your parallel lines, all three of them here. So that's also going to be 38. And obviously base angles in an isosceles are equal, so this one up here is also going to be 38. There we go. Obviously these two angles underneath those little dashes there are both equal. So to get this angle here, okay, all we need to do is take those two away from 180. So 38 plus 38 is 76, and 180 take away 76 is 104. So that one there is 104 degrees. There we go. And moving on to the bit at the bottom, okay, obviously this is all the same, okay, so we've got, if I get rid of some of this highlighter, let's get rid of that, I can highlight this on the other side as it's a mirror image, so that's also going to be 38. So that one there is 38 as well. Again, this is an isosceles, the angles underneath are equal, so this one is also 38 and this one here is also 104, using the same mathematics that we used on the one above. Now we can finish off the question, because you've got, and this hasn't actually come up yet, we've got angles all around a point. Okay, all these angles around a point add up to 360. So this final angle, let's just get rid of this. There we go, this final angle here is whatever makes it up to 360. So we've got 104, add another 104, that equals 208, and we just need to take that away from 360. There we are, and we get 152 degrees. There we are. So 152 as my final answer, and we'll just highlight that. There we go. So just last little thing, thinking about all the reasons we did there. First things first, what I did was alternate angles are equal, just here. Then I did base angles in an isosceles are equal here. Then for this one I did angles in a triangle, add up to 180. I did the same below, again, alternate angles, base angles in an isosceles, angles in a triangle. And then once we had those, we finished it off by getting our angles around a point equaling 360 for this one here. And obviously you wouldn't have to mention all of those, because obviously we did the same on the top and the bottom, but you would want to mention, there we are, let's just get rid of all of that. You would want to mention what you did on the top there. And then obviously when you replicated it down the bottom, you wouldn't have to repeat yourself. But there we go, that's how we get our answer. So that's how we approach some of these questions with angles in parallel lines. Obviously the majority of these questions I did use alternate angles, and have a look at that. And that rule bit of alternate angles being equal I think is very, very important. Not that any are more important than the others, but I do just notice on questions I tend to use alternate angles a lot more than any of the others, okay? Obviously once we get parallelograms involved and stuff like that though, you do need to know those co-interior angles, adding up to 180 and stuff, so please don't think that you don't use them as much just because we used a lot of alternate angles here. But as I said, I do seem to find that I use them a lot more than any of the others, so do make sure that you are super confident finding alternate angles. But there we go, that's the end of the video. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.